I'm going to walk you through an MP3 player that I built for my microcontrollers class. So this class used a TM4C microcontroller, and I basically have all the parts listed out on the picture on the left here, and I'll just walk you through each of them. So starting from the left, there's a micro SD card with 30 songs loaded onto it that is being loaded into a micro SD breakout board that is being read by the microcontroller. It's being read through an SPI, or a serial peripheral interface, and it uses a master and a slave in order to communicate along with a chip select. So in this case, the microcontroller is the master and the micro SD reader is the slave. Then moving over to the right, we have a LCD adapter board and display. The display is screwed in at the bottom there. There are about 12 different wires going into the adapter board, and this just allows me to turn it on and off and set certain LED pixels on. This LED screen is a 8x20, so there are 8 rows and 20 columns, and each one of those can contain various characters that I have set in the coding part of this video. So continuing to move over to the right, we have a DAC, which is a digital to analog converter. The data from there is being fed into an SOIC to DIP adapter. So that's a small outline integrated circuit, and it is going into a dual inline package. From there, we have various capacitors, 100, 1, and 0.1 microfarad capacitors that are then going to an audio amp, which is connected to a headphone jack. And from here, we can capture the audio that is coming from the micro SD card. On the bottom right there, we also have a 4x4 keyboard, and in this case, the columns are acting like outputs and the rows are acting like inputs. So in this setting, we're able to read whenever the user presses a button, and when they do press a button, it will send an interrupt to the microcontroller telling it that the user has interacted with the MP3 player and will perform its necessary function. The picture on the right goes more in depth on these GPIO pins, which are general purpose input-output pins that are basically the peripherals that allow the microcontroller to talk to the different wiring and components that are connected onto the breadboard.
So my MP3 player itself has this specific menu that's shown right here. So it has the title of the song, the artist, the album, the time elapsed, the next song, that's the song number that's playing right now, the volume, and different menu buttons that show what can be pressed at any given time. So I'll go through the different button functions. So I'll save pause and mode for last, but B is sequential and shuffle mode. So this can toggle between the two different modes, and you can see when that happens, the next goes to a question mark in shuffle mode because you don't know what the next song is going to be. So we'll go back to sequential. Volume will increase the volume as you've seen. Has a max of 32. You can decrease it down to 0. How to take into account it can't go past the max volume or can't go below the minimum volume. Then you can press previous song, which will go to the previous song. You can see it on the song number here. You can go to the next song. You can see it going to the next song. And you can see every time I press that, the time resets, so that also had to be taken into account. Similarly, when you press A now, you go into song selection mode, the timer had to be stopped. So we have the ability to enter a song that you so desire. So you can say we'll say 12. So this has to be 1 to 30 because I said there's 30 songs on here. You can press enter, that'll instantly press song 12. We'll go back to that mode. So if you say you want to do 22 and then you're like, oh, I don't want to do this anymore, there's a clear button here. So we can clear that entry, it'll reset. Then we also, if you enter an invalid number, so let's say 35, and you press enter, it'll unpause song 12 because that's not a valid song, so it doesn't take that as an entry that had to be taken into account. We have a queue here, a queue of 3 songs that you can play, so it basically acts as a playlist. We'll add song 6, you can press add to the queue. We'll say song 7 added to the queue and song 20. If you want to delete a song off the queue, you can press D. So let's say you have 7 and 20 in the queue. We'll go back to playing, still in song 12, but we can see that the next song is song number 7. So if we click next, we should see that it's 20, and that's how it is.
So I'm going to explain some of the code that was used in order to create this MP3 player on the microcontroller. So this code was written in C, and it was created on Code Composer. So I'm not going to go through all the different files because there are a lot, and it is worth noting that this was a course I took, so some of the code was provided for, but I did write and create a lot of this code by myself. So in this first file, we have the gpo.h, and this is basically where we're assigning the different GPIO port numbers, so those list of pins and their base addresses, just setting them as variables. Also, the different pin numbers associated with each of these ports, the port A, B, E, D, so on. And there's also these different offsets of registers that are located, or that each of these base addresses have. So this file is the GPTM timers, so the general purpose timers. There are 3 used for the MP3 player. The 4th one is something I developed all by myself, and I'll go through that. And there's lots of different controls that can be found within the data sheet of the TM4C, and they basically just have to do with interrupt statuses, enabling them, whether or not they're periodic, 32-bit timers, etc. This is the main function for the MP3 player. So we're basically getting song data from the micro SD card, initializing the sound, initializing the timer, and lots of different initialization functions, some of which I'm going to explain in these further files. So this is the sound.c file, and this is just basically showing how the data that we've retrieved from the micro SD card is being put into the DAC and converted into audio. So we use buffers for this. We're getting all the data and setting certain amounts to make sure that the buffer does not overflow, and when it empties, we are refilling it until all the song data has been accounted for. So this is the control.c file, and this will allow the user to interact with the song, so shuffle it, pause it. It'll also notify whether or not the song is finished or if it's continuing to play. So these are just some of the functions. So the number of songs that are being read from the micro SD card, yeah, like I said, whether or not it's done, shuffling it, pausing it, going to the previous song, getting the song number, which is something that was used in other files. So this is the UI.c file, and this basically allows the user to interact with the MP3 player itself. And so there's different buttons associated with different commands for the MP3 player. This is the matrix of different characters that show up on the keypad itself. So you can look at the video and see that this is exactly the same. The rows are assigned to certain pins and the columns are assigned to certain pins. So you need 8 in order for the keypad to be read. This will determine whether or not the state is pressed or hasn't been pressed. And then it'll also use this lookup function to find out which button was pressed. This UI handler basically takes in all the different cases. Depending on which button has been pressed, it'll perform certain commands, shuffle, up volume, down volume. Can also create cues or go to a different song, and depends on what mode that the MP3 player is in, whether it's in song selection mode or just playing a song in normal mode. And you can see the different modes in the other video. Initializes the user interface, and this function down here is just displaying the various commands and characters to the LCD itself. So if it isn't paused, it will be in normal mode where it is just playing a song. So this is what the LCD will show of various sets of commands to also get song number and get volume are called in here. Displaying the menu. Else, if the song is paused, we're in song selection mode, and we can do stuff with the queue and add various songs. This is the function to handle getting data from the micro SD card. So different commands have to be sent to the micro SD card in order to start being read. Some of these commands were read with an oscilloscope, so to make sure that they were happening in the proper order. Some of this code was provided for too, so I basically was tasked with making sense of making sure all these commands were sent in the proper order and that we're actually receiving data from the micro SD card itself. So a couple of the files were written in assembly code. So this is ARM assembly. In the beginning here, we are defining some of the registers that are going to be used and some of the variables for the rows and port arrays. So in here we are setting up all the different ports. So turning them on, turning system control on. This is just initializing them. And here we are setting all the rows, certain directions, pull up, open drain, and enabling them. This is for the rows, and this one is for the columns. Similar process, whether or not it's an input or an output, it will have different commands and will set different bits on and off. So here we are setting one of the rows to be high and all the others to be 0. And by doing that and having all the columns be inputs, we can determine which of the keys has been pressed. So this will get the key. This part of the function is labeled to get the key. This will have certain branch statements depending on the state that is loaded into these different registers. And yeah, this is just various loops it'll go through in order to obtain the correct key. And finally, this is one of the timers that I set up for in the explanation video going through the elapsed time feature that I implemented. I had to write all this code, basically turning the system control timer on, setting it to be periodic, 32-bit timer. I went through a lot of that in the video, setting the rate.
So I'm going to go through one of the features that I had to implement, and that is the elapsed time. So as we can see, this elapsed timer is timing up every second. And if we pause it, we'll see it's at, and we come back and unpause it, it'll go back to where it was. Also, if the next songs are played, it's going to reset. So all of these things had to be taken into account when designing it. So I decided to use timer number 4. So you need to enable multiple registers, which are basically 32-bit addresses that are stored within the microcontroller itself. So if you access a certain address, it will go into that data memory and turn certain bits on. So that's what I'm doing in these first few lines. You can see in these brackets here, these are actually offsets. And then right here, I'm turning on or turning off certain bits itself. So this makes it a 32-bit timer. This makes it able to be periodic, so it repeats the same way. This is enabling interrupts. So when the timer times out, it will reset itself. This is doing kind of the same thing. So the interrupt itself had to be accounted for. So I created a function in the interrupt table that would increment a reload counter, which was assigned as a 16-bit variable. And that basically every time the timer timed out, which is operating at a 120 megahertz signal, you'd have about 2 to the 32, so about 4.2 billion bits, or like a counter going up. Once it reached the end of that counter, it would reset, increment this reload timer, and then continue to go. Once that increment reload timer was called, it would basically act to increment that variable. I'll show that on the next page. The enable timer was basically a function that you could pass a Boolean argument into it. Enable would enable the timer, false would disable the timer, and that's like if I needed to pause it. or resetting the song. I just set the rate, so I would pass an argument of 1 into here to operate at a frequency of 1 hertz, and that would increment once every second. So if I wanted something to go 20 times every second, then I could pass in 20 to here, operate at 20 hertz. This function clears the timer. This is one example of using the enable timers when we're pausing it. So this is the increment reload function I was talking about. So this just increments a reload variable and allows me to keep track of the number of seconds that are happening. This is a reset counter, so when I'm going to the next song or choosing a certain song, it will reset that counter to allow it to go back to 0. I have a reload counter function will pass this reload variable into other files within my project that allow me to keep track of the number of seconds and use it in other places. This is basically an algorithm that will take that number. So here's the reload counter function. I'll take that number, and I employed this function, this algorithm, to take that number and calculate the number of minutes, the 10 seconds place, and the seconds place. And that allows me to input or output that timer looking elapsed time.
Thanks for watching, and I hope you enjoyed learning about the MP3 player that I built.